So this one again, we have to look at a general term first. So let's expand. If we were expanding this out, we would get 7, choose some k. First term in index form is y to the negative 1. So let's make that 7 minus k. And the second term is negative y squared on 2. And that would be to the k. So if we have a look at just the y, the powers of y in here, this bracket would be giving me y to the k minus 7, because it's minus 1 times 7 minus k, so it's k minus 7. And this other bracket would be giving me y to the 2k. So what do I want it to equal? In this first case, I want it to equal y squared. So let's have a look at the indices then. Adding the indices, we would get 2k plus another k minus 7. So that's going to be 3k minus 7. I want that to equal 2 in one case. And in the other case, I'll just get it ready, 3k minus 7, we want it to equal y to the 5. So I want that to equal 5 in the other case. Okay, so 3k here, of course, equals 9, so k equals 3. In part B, 3k here equals 12, so k equals 4. So I'm looking at k equals 3 and k equals 4 for B. So for A, with k equals 3, sorry about that, let's go back to here. So we've got 7 choose 3, y to the minus 1 to the power of 4, minus y squared on 2 to the power of 3. So for B, which is k equals 4, we're going to have 7 choose 4, y to the minus 1 to the power of 7 minus 4, which is 3, minus y squared on 2 to the power of 4. Alrighty, so let's have a look. What is 7 choose 3 is apparently 35. So we've got a 35 here. We can check it's y squared, this one, by just checking this out. So we know that'll be like that. This one, interesting one, it's negative or cubed, so we know it's going to be a negative. I might put that at the front. Y squared cubed is y to the 6. And at the bottom, we've got 2 cubed, which is 8. So if I just want, so we are going to get a y squared. So if I just want the coefficient of y squared, I've got minus 35 on 8, whatever that is. Keep it like that, that looks nice. All right, let's do our other one. So we've got 7 choose 4 for the other one, 35, of course it is. So 7 choose 4 and 7 choose 3 by the symmetricality of that Pascal's triangle. They're going to be both the same. So that's 35. This is going to be 1 on y cubed, so we can check that this works. Minus to the power of 4 is positive, so we can ignore that negative. And we're going to, y squared to the power of 4 is y to the power of 8. 8, 7, 6, 5, so y to the 5 is correct. Now don't forget it's got a 2 on the bottom. 2 2s are 4, 4s are 16, so we've actually got a 16 there, 1 on 16 as well. So that means that, whoops, the coefficient that we're looking for of y to the 5 is 35 on 16.